Good day, my wonderful learner. In this course of study, we are going to be looking at dimension and physics. The first dimension we are going to be solving is velocity. And what is the derivation for velocity or the formula for velocity? Velocity refers to displacement over the time. That's displacement per unit time. Now, let's look at how to solve for the dimension. We have velocity to be equal to displacement over the time. Now, one thing we need to know in dimension is that we make use of three basic quantity, which is mass, length, and time. For mass, it is represented with m, capital letter M. For length, it is represented with L, while for time, it is represented with T, M, L, T. Those are the basic three quantity we make use of in dimension physics. Now, let's look at the dimension for velocity. We say is displacement over time. When we are talking about displacement, this refers to distance. And when we are measuring distance, it's just the same thing as length. So we have length. Now, over time, that's over t. Now, let's get the dimension for it. We have velocity to be equal to displacement is referring to distance, which is L, that is length of a place, over the what? Time, which is t. I told you for time, you represent it with t. Talking about distance, we represent it with L, which is still the same thing as length. Now, let's move ahead. Now, this t we need to move up, so we rewrite it as LT inverse. That is the dimension for velocity. That's why you see anytime you are solving and you solve for velocity, L is referring to length, and length is always in meter. Time is in seconds, so you have it to be meter per second. That's the SI unit, the System International Unit for velocity. Now, the next thing we are going to be checking is called acceleration. Acceleration refers to change in velocity over time, or velocity per unit time. So, we have acceleration will be equal to velocity over time. Now, if you can remember, we've already derived velocity. We've solved for the dimension of velocity. Now, let's input it that for this, we are going to have LT inverse raised to the power of -1 over time over t. Now, this is going to come up, so we have it to be LT -1. This is coming up. To meet it, we have another -1. In mathematics, -1 minus 1, which is going to give us -2. So we have it to be LT -2. So this is the dimension for acceleration, and that's why we always have length is in meter, time is in seconds, then we have -2. That's always, anytime we make calculation on acceleration, we always have meter per second square. Okay, now the next one we are going to be checking is called moment of force. The third one, we have this to be number 1, we have this number 2, the next one is number 3, which is called moment of force. Moment is giving us force times distance. Now, in this case, we already know that distance, the dimension is length, because it's talking about from one place to another, which is known as the length. But force, we don't know the dimension, so we have to solve for it separately. We say force equal to mass times acceleration. Mass times acceleration. Mass, if you can still remember, I told you that for mass, you represent it with m. So this one is going to be m. So we have it to be capital M multiplied by acceleration. We've already solved for it, so we just have to bring it up here. That's going to be LT -2. So together, we're going to have the dimension of force to be MLT -2. That's why anytime you solve for force, you are going to have this. Mass is in kilogram, length is in meter, time is in second. You have kilogram meter per second That's anytime you solve for force, or you have your force to just be in Newton. Now we have our force to be in kilogram meter per second, which is mLT raised to the power of minus 2. Now we have our moment to be equal to mLT minus 2, okay, multiplied by distance is in length. I told you before, that's going to be L. Altogether, we are going to have mL. Remember, L times L is going to give us L squared, t raised to the power of minus 2. So this is the dimension for momentum. So the fourth one we are going to be checking out is the dimension for volume. Volume of a cube is given as length times breadth times height. So we have volume to be equal to length times breadth times height. Now if you check it out, length, we already know the dimension is just L. Breadth is still talking about distance. So the dimension of length is L. The dimension of breadth, since it's still talking about distance, is still L. And the dimension of height is still talking about distance, how high something is still L. L multiplied by L multiplied by L. Altogether we give L cube. So this is the dimension for volume. That is, anytime you are solving for volume, you always see it meter cube, centimeter cube, millimeter cube. Those are the dimensions which are involved. These are some of it. I'm going to treat another one in the next class. Please, if you haven't subscribed to my YouTube channel, kindly subscribe at j_math_and_science. Please do well. Thank you, my wonderful learners.